don't let me forget I've got 2 worksheets to hand out to you at the end of class today. Okay? So, here's how we're going to start class today. Oh, come on. Make it work.
Hey, Benefit. Yeah. Hear about ice? What's that? Want another one? Really? Yeah. I feel the need for speed. Ow!
Alright? Feel the need. The need for speed. If you have the 4.B worksheet, this is like the bottom one on that page, just so you know too. Okay. So, we've got a motor. Come on. Try this again. So we've got a motor that's running a saw, right? And they're connected by a belt. Okay? So we need to find the angular speed of each pulley. Well, the motor here is spinning at 1,000 go to your home. The motor is spinning at 1,450 revolutions per minute, correct? Okay. And I need to get that into radians per minute. So that means that 1 revolution is 2 pi radians. So that tells me that that motor is spinning at 2,900 pi radians per minute. Agree with that? Okay. Now, you got to use some logic here in going to the other pulley. Okay. So the motor, the small pulley, is spinning around and around and around. Okay. The big pulley is also spinning. Okay. But are they spinning at the same rate? No, because they're not the same size, so they're not spinning at the same rate. If they were the same size, they would be spinning at the same rate. Okay? But they're not the same size, so their speeds are different. Okay? So, what's connecting the 2 pulleys? The belt. So we have to find the speed of the belt because that's what's constant between both of them. Okay? So to get to the saw here, I have to use the fact that the belt is spinning around the small motor at 2,900 pi radians per minute, which translates then into a linear speed of, so the radius of the small pulley is 2. Oops, wrong spot. Wrong spot. Radius is a radian, so that takes out my radian, and that is 2 inches. Okay. So now I have the linear speed of the belt. Okay. That belt is always going at a constant speed. The pulleys are spinning at different speeds, but the belt is going at one speed. Okay? So now I can transfer over to the saw. So the saw now has a 9-inch diameter pulley. So on the saw, 4.5 inches is 1 radian. And I'm back now into radians per minute. Okay? So I believe that that one ends up being 11,600 pi over 9 radians per minute. Let me check my notes. Yes. Okay. Yeah. Because, so this dividing by 4.5 is really dividing by 9/2. So when we divide by a fraction, we flip and multiply. So that's really multiplying by 2 over 9. So it would be 2,900 times 2 times 2, which gets me 11,600 times pi then on top. And on the bottom, then it would be 9. Okay? What's up?
Why do you multiply by 2 twice?
So, if I was doing this math, this whole 1 over 4.5 is really 1 over 9/2. Okay? And so to divide by a fraction, you flip the fraction and multiply. So this part right here, this fraction right here, is really like multiplying by 2 radians over 9 inches. Okay? So if now we'll see if this is doable. If I were to, no, see, can't do it that way. If I were to pick the right thing, there, pick that, so that would take over right there. Okay? So then 2,900 pi times 2 times 2, all over 9. Try it. Oh, see, now they're all goofy. So what if I can go like this? There you go. Okay? Part B then says, find the speed of the saw in revolutions per minute. Well, the saw is spinning at 11,600 pi radians per minute, or excuse me, per 9 minutes. And that then needs to be multiplied by the fact that there are 2 pi radians in 1 revolution. So that gives me 5,800 over 9 revolutions per minute, or 644.44. Well, so you're going with the saw, right?
I get that.
Okay, so that's this one.
Yeah.
Yep. Okay. So now I want it in revolutions per minute.
Right.
So 1 revolution is 2 pi radians, right?
Yeah, what are you multiplying and dividing to get that?
So 2 goes into 11,600, 500, and or 5,800 times, right? Pi cancels out pi. So I'm left with 5,800 divided by 9. Okay? That part I thought you knew that one. My bad. Okay. Good with that one. Question for you. Anybody ever read the Hardy Boys books? Or Nancy Drew? Or when Nancy Drew met the Hardy Boys? Don't want this. Come on. While the clock ticked at the Purdy house. Okay? So we're figuring out here. Now for me, I like to draw myself pictures. I'm not very good at drawing myself pictures, but I don't have to be very good at drawing pictures, just so I get a general feel of it. Okay? So the grandfather clock at the Purdy house is 44 inches long, and it swings through an arc of 6 degrees. So that's a 6-degree angle right there. So I need to find that distance, given the fact that this is 44 inches long. Okay? Try it. So what's the first thing that you've got to do in this problem? Switch from degrees to radians. So 6 degrees gets multiplied by pi over 180 degrees. So that gives me pi over 30 radians. Okay. Then S here, my arc length, is going to be equal to theta times my radius. Theta needs to be in radians, which is why we switched to pi over 30. Oops, that's a bad 30. And my radius is 44 inches. Okay. So that ends up being, let's call my arc length here 22 pi over 15 inches. If I divide the 44 by 2 and divide the 30 by 2. Okay. Or approximately, somebody help me out that's got a calculator, 4 point something, right? 4.608. Okay. Questions on that one? ODs, that's Olivia Draggers. Racing bike wheels are 28 inches in diameter, and for the high gear, the pedal sprocket is 9 inches in diameter, and the wheel sprocket is 3 inches in diameter. Find the angular speed in radians per second of the wheel of both sprockets when she reaches her peak racing speed of 66 feet per second in high gear. Okay? Go for it. Try this one more time. Oops, maybe. Try that one more time. Now it should play in the background.
Okay, here we go. Focus. Speed. I am speed. 1 winner. 42 losers. I eat losers for breakfast. Breakfast? Maybe I should have breakfast. Oh, brekkie could be good for me. No, stay focused. Speed. I'm faster than fast, quicker than quick. I am lightning.
Hey, Lightning, you ready?
No, you're doing a problem. I know, that's the problem.
Okay, here we go. Focus. Speed. I am speed.
And land out.
How many angular speeds do we have to find? Angular. How many do we have to find? Like the wheel and the wheel sprocket are spinning at angularly, they're spinning at the same speed because they're on the same axle, if you will. Okay? Which, if you found 3 of them, you would have found that 2 of them were identical. Okay? So let's start with the wheel and the wheel sprocket, since those 2 are identical.
Yeah, fuel and tires. Your suspension stance look good. Tire pressure is excellent. As they head into the Palace hairpin, Francesco builds in early lead. Oh, hang on, boys.
Okay? What do we have to start with?
Lightning McQueen is the first to take advantage. And just like that, folks, Francesco's
So what kind of a speed is that? That's a linear speed.
Well, he's got some serious work ahead of him if he wants to get back in this race.
Okay?
Now the racers hit the Rainbow Bridge.
We want to be, in the end, we want radians per second. Correct? So we've got to take feet, because seconds are already seconds, so we've got to take feet and turn it into radians.
Let's keep this line clear.
Okay? How do you want to do it?
Number 10, Klutchkowski.
And here they come, the 2 leaders.
They're bumper to bumper as they approach the finish line.
It's going to be close.
Francesco's the winner.
Okay, so first get it into inches. Okay?
What happened? Is the race over? You won, right?
Mater, why were you yelling things at me while I was racing? I lost the race because of you.
Well, I'm sorry. I didn't mean
An
to.
imaginary girl.
So now I'm in inches per second.
This is exactly why I don't bring you along to these.
Now what?
McQueen, you had it in the bag.
Yeah, what happened?
I made a mistake. But I
Okay.
can assure you, it won't
Because
happen again.
the linear speed is the outside of the big wheel, right?
Means some to suggest that
Okay.
the fuel
So that one then is going to be
Oil is safe. Alternative fuel is
14 inches
high fuel cause these cars
is
flame out.
1 radius, which is a radian, right? Okay.
I don't want to be the cause of you losing any more races. I want
And that gives you, is that in the units that I need it to be in?
you are the greatest race car in
Yep.
the whole
Okay.
world.
So let's do some simplifying.
Mater.
2 goes into 14 7 times. 2 goes into 66 33 times. So that ends up being
I just really wish Mater were here.
396
Oh, great. Here it comes. What do you got, Francesco?
over 7 radians per second, correct?
That's exactly.
course. And my mama is right here. Mama! Don't worry,
Right?
Mama. McQueen is very sad.
So if I were to put a point on the outside of that wheel and put a point on the outside of that sprocket, those are spinning around at the same angular speed, correct? They're spinning around at the same angular speed. Okay? So that's the wheel and the wheel sprocket. Now we have to go to the pedal.
We figured you might stop by.
Okay. So
Number 7 is loose. Shoot Todoroki.
this chain right here
Bumper to bumper as they approach the finish line.
is the connection between the two sprockets, correct?
I have no idea what happened.
Okay, so we gotta find the linear speed of that chain so I can jump to the other sprocket.
I called to talk to Mater.
Okay, that sprocket down here on the wheel, or excuse me, down here on the wheel sprocket, or that chain I should say, is spinning at 396 radians per 7 seconds. Right?
Everybody get out! Get out now! Y'all gotta get out the pit. Hey, what are you guys doing here?
We're here because of you, Mater. Is everything okay?
What's the radius of the wheel sprocket?
Stop right there! Don't come in!
Of the wheel sprocket. What did you say? Okay, I thought you said 4.5 the first time. Okay, so 1.5 inches.
I know I made you feel that way before, but none of that matters because we're best friends.
Is 1 radian
Yes, Mater, you are the bomb. That's what I'm trying to say here.
on that one.
Always been the bomb.
So now I have the speed, the linear speed of the chain. So now I can jump to the other sprocket. Because that's how they're connected. You gotta think about how they're connected. You know what I mean? You got this pedal over here and this wheel sprocket over here. They're connected by a chain, so you gotta use the chain to get to the other one. Okay? So now I'm over on the other one. And what's the radius of that one? What's the radius of the pedal?
Mater!
4.5. So then that would be
Welcome back!
Mater, it's so good to see you.
You too, buddy. Oh man, you ain't gonna believe the things
4.5 inches is 1 radian. And I'm back into angular speed, correct?
Faster, come on, faster.
Even better.
Okay.
Me and Miss Sally going out for supper.
Mater,
So that one
just me and Sally. Oh. I can't tell you how good it is.
ends
to be here
up
alone, just the
being
two of us, finally, you and me.
132
My name is Mater, and I'll be your waiter.
The Lightning McQueen.
over 7
Against Francesco. I can go over
radians
300 kilometers an hour.
per second.
Miles. That is like,
You know what? They just got back. Deal me in, baby.
Because it would be 396 over 7 times
No, I just got
3 over 2, that's the 1.5, times 2 over 9.
Okay, now, Mater, remember, best behavior.
You got it, buddy. Hey, what's that?
Mater!
Hey, McQueen.
And then 3 goes goes into here. One.
This isn't Radiator Springs.
You're just realizing that? Oh, that jet lag really done a number on you.
Mater.
Hey, Lightning McQueen! Buonasera!
Now, if you rounded those, the first one, so this one would be 56. Point 571.
You had one of those made up for all the racers?
No.
This one would be
Lightning McQueen! Good job! Thank you so much for having us, Sir Axelrod. I really look forward to racing. This is a great opportunity. Peter, you have